Welcome to a lesson with Dr. Powell. Let's give some names to some things. Suppose we have a function of two variables, fxy is equal to x to the fifth, y plus y squared, x, something like that. Okay, now we've been talking about the derivative of the output with respect to just one input, treating the other one as constant. We have some notation and some names for that. Well, usually when we think of derivatives, we use a d. This isn't quite the notation we use, though. We actually change this d just slightly. So it looks like that. Becomes a it's a Hebrew letter right there. Actually, this is the way we usually write it, like that. What this means, means the derivative of f with respect to x, where we're just treating all the other variables as constant. That's all it means. It's just kind of remembering that only the x is the only variable that's changing. And we call this a partial derivative. The partial derivative of f with respect to x. Another way of notating this sometimes is just saying f and putting a little x there. Both these things mean the same thing. Sometimes this notation is more common, but this is also used. You'll see both of these notations used interchangeably. They mean the exact same thing. So maybe for now we'll use this one. Let's compute it. What is fx? Or the partial of f with respect to x. So we treat y as a constant, and we come through here and we see that we get 5x to the fourth, and y is just a constant. So we just have y plus, so here we just have y squared. So this would be the partial of f with respect to x. Compute the partial of f with respect to y, and we would end up getting x to the fifth, because x fifth is constant, so it's constant times y, plus 2yx. 2y and then x is constant, so just multiplied on. So that means that in particular, the derivative or the total derivative of this could be written as a matrix as follows. Just 5x to the fourth y plus y squared, and then x to the fifth plus 2yx. Another way of notating the total derivative is just like this. Fx, Fy as a matrix. Now, in the book and other places, you may see this. You may see that we have this notation. This is called del f, or gradient f, gradient of f, and this is often notated like this in vector notation: fx comma fy. It really functions the same way as this does, where we have the notation df. Both of these are the same, just sometimes interchangeably used, but this one refers to, emphasizes the fact that we're thinking of a vector now instead of a matrix. So that's the emphasis here. But it really is the same basic thing if you look at it. Thanks for watching.